Well, good morning, everyone. It's 8:30. I want to respect time of those who came on time. So let's start. Let me restart my timer here. So no t-shirts today. I do have stickers if anyone wants afterwards. So my name is Václav Petráš. I usually go by Vašek, and I will bring you into the weeds of GRASS today. I am a research software engineer at NC State Center for Geospatial Analytics, and I also am part of GRASS core development team, and I'm a member of the project steering committee. GRASS is a project of OSGeo, Open Source Geospatial Foundation, and I'm charter member of OSGeo as well. The talk I will be showing and all the cool tools and features are not just work of myself, but the work of whole GRASS community. Some of them you can see on the picture. Myself highlighted with natural light. That's not staged or modified afterwards. They just worked out that way. And I have some natural abilities to have my head highlighted even more. So here we go. And what is GRASS? GRASS is a geospatial processing engine. It has more than 400 tools for geospatial processing, with another 400 tools in GRASS add-ons, which you can install to the base software. The primary interface is a Python API used in Jupyter Lab. So here we can see an interactive map rendered in that Jupyter notebook. But there are other interfaces I will get to. We just had a new release, 8.4.1. And how the releases work is that we have a stable release that would be the 8.4.1 at this point. That's your current everyday user version, which you can download for different operating systems. But we have also a daily preview version, which is using the latest reviewed functional code. So this might be a little less stable, but at the same time, it's reviewed and vetted. And then we are also maintaining a legacy version for some legacy production systems. So that's currently version 7.8. If the last time you used GRASS is something like GRASS 5 or GRASS 6, since GRASS was there 10 and 20 years ago already. There were some changes, so you may want to check, and I will focus now on the changes in between just the version 8.3 and 8.4. We got some new additions for machine learning, specifically support vector machines. This comes with two tools. One is for training, and the other is for predicting. And this functionality is also using some new additions to how remote sensing data in GRASS is handled. And there were specific improvements to how these are handled for machine learning to make the machine learning algorithms or workflows smoother. We had other additions for topology handling, specifically a tool called vFillHoles. That's vector and fill holes. It's filling your empty spaces in polygons. And then a more low-level tool, RHorizon, Raster Horizon, which is used in a backend of different line-of-sight computations or solar radiations. So this tool has new outputs, which can then be used to build more advanced workflows. And in terms of interfacing with these tools, we are adding JSON output to a lot of tools which have textual output and which create some metadata information about the data. And another case is this VDB select tool, which is a vector database selection or querying tool. And by default, it gives you attribute table, or you can do queries. And this can now do not only CSV, comma separated output, but also JSON. And then in Python, this JSON is very easy to ingest. So the workflow of using the data in Python is now much simpler. In upcoming version 8.5, we will have even more tools which will have that interface. Another change we did for 8.4 is that locations are now projects. So location is a way how to, or project is a way how to organize data in Grass, and we are now adopting a new name of project. It should be very smooth in terms of what you expect a project for a software would be. All your data in Grass lives in a project. And what the projects are good for is that they help you keep your data consistent. All the data in a project is in a Grass native format, unless you link external data. All the data inside a project have the same coordinate reference system. So the idea is that you do all your data preprocessing, format transformations, or coordinate reference system transformations ahead of time of your analysis. And then when you have the data ready, you just focus on your analysis. So you are kind of separating the concerns here. And map sets are sort of working as sub-projects, where a project can be divided into multiple map sets, and that helps you keep the data organized. And you can, again, separate the different tasks to different map sets. And that way, you can protect your data from being overridden by your new outputs, or you can just separate the data into multiple categories. If you don't have to use map sets, you can just use one map set per project, and that's fine. It's very often used, this workflow is very often used in scripting. And with that, we also made it much simpler to create projects in Python. We had sort of a chicken and egg situation where you first had to create a project, and only then you could use fully featured Python API. But now you can create a project and then tell Grass which project you want to use, and you have that. You notice that at the end of the slides, I put there who did that, just to be clear that this work is something I did with funding from a Raleigh-based company, Natrix, but other things are done by other people, so I'm just trying to be clear about that. And Grass also has a command line interface, and there we did the same change, that what was called location is now called project. And the nice thing is that the old things in the command line keep working the same way. That's sort of also expressed by the way how we version the software. We are using something which is called semantic versioning. So the new version is 8.4, and we didn't change the first number. It's still 8, which means that the old stuff still works. And that's a big value in the community, that the old things keep working, although there are new improvements on top of that. And then only with a big warning, we are changing the major things. Which brings me to a more long-term view of the matter here. So Grass is actually a really good career investment, in the sense that similar to other technologies, it is not a technology which will disappear in a couple of years, and the technologies used in Grass itself are similar in that way. So the command line on Linux, that would be bash scripting. That's something which is here for tens of years. If you learned it in 90s, it's still there. I learned it in 2010s, and it's still here. There were many improvements in how the syntax is done, what is the safe way of doing things, what is the best practice, but the general ideas stay the same. The same applies to Python, which is a little newer than that, but still has this long-term vision, and Grass also works in the same way. What these tools have in common is not only longevity, but also the fact that they are open source, and that kind of lends itself to more stability and longevity, and they are also platform independent. So they right away from the day one work on multiple different platforms, meaning they work on Mac, Windows, Linux. So they can easily work in cloud, and if there is something beyond cloud, they will work on it as well, because that's just what they do. They always just work on any platform available. There are, of course, things being added, as I said, and here I have an example of code which I took from a book about Grass. It's from 2002. It has code for Grass version 5. It's actually a pre-release of version 5 even. And it's a raster algebra expression with a tool called RMapCalc. And the raster algebra expression works as is in the new version of Grass. I put there 7.8, but I meant to put there 8.4. So even in 8.4, it still works as is. And the only difference now, which I would do with this expression, is that I would format it a little differently, put spaces and quotes in different places, and name the variables a little differently than what was done before. That's more based on like what is also done in Python and influences like that. But other than that, the expression is the same, and even the original expression would still work. So this is something you get with Grass. There are other functions in raster algebra which were added since then, so you can use more, but the old stuff continues to work. And the other side of this is that Grass is licensed under an open source license. It's specifically licensed under GNU General Public License, GPL, and this license is focusing on user freedoms. It prioritizes user freedoms over developer freedoms. There is some discussion to that, but what it means for organizations is that with this open source licensing, you are adopting a product which is provider or contractor independent. You can keep the same product and exact same solution, and even when you need to do something in the product itself, you are not dependent on a specific provider. You can choose your provider freely, and they just contribute to this open source neutral project. If you invest into it, especially in public sector, the investment stays public because it's in this public pool of code, which is then used to build the project. But then there is also the fact that you don't have to actually pay just to use the software. You don't pay any usage license. You pay for support and new features. So you pay for the extras really here. And the other side of that is that there are no per user or per CPU license fees. You can deploy it on as many cloud instances or as many desktop computers you want. And for individuals, you can work with the same software in your work or personal laptop. A lot of government offices on different levels, they allow Grass or QGIS with Grass to be used already now, or you have to go through the approval process. And of course, then you can use the same thing at home because the license allows you to just use it at home as well. And you can take this knowledge with you to a next employer, whether or not they are a big GIS shop which is having some specific license of a software which your previous employer had. But there are more features in 8.4 I want to tell you about. We have more additions to the Python API, specifically to the interface with Jupyter Notebooks. So I have showed the map at the beginning when I started to talk about Grass, and that's these images in Jupyter Notebooks are done by Python classes or objects, and we improved two of them. One is actually addition, a series map, which is animated a series of maps, whether they are rasters or vectors, and this is sort of an extension of an existing functionality, which is for animating specifically temporal data. So for that, you would have to express your time component in a full way, which is possible in Grass, but this new series map allows you to just do very simple, quick animations without dealing with a time component. And another addition is that we are adding interface with IPyLeaflet, which is a library in Python providing a lot of interactivity. So you can do a lot of clicking in that map, zooming, and the things can go back to Grass as well. So you get kind of a very interactive desktop GUI-like experience as far as the map is concerned. But in the desktop graphical user interface, we also had several additions. One of them is that we have a new history browser panel, which shows all the previous tools you were running and their parameters. You can browse through them. You can see the results, whether they succeeded or they failed. And the history was always saved in the graphical user interface. So if you are using Grass now and you use the new version, the history panel would show the previous tools and runs you did. It was just more difficult to find it before, and now it's readily available in an overview. As far as additions to tools, in the add-on repository, there are tools which are contributed by a wider community, and they are possibly not ready to be included in the main installation. One example there is our wind fetch, which is computing a distance which wind blows over a surface unobstructed, so that can tell you how big of a wave you eventually should expect on a lake or in a bay. And that's one of the improvements which is enabled by the R Horizon improvements I mentioned earlier. Another tool in the add-ons repository is actually a set of tools for digesting remote sensing data with a library called EODAG, which is providing us with many different remote sensing data sources, and the tool set can do everything starting from import from some data store to pre-processing, cloud detection, and masking. So all the remote sensing tasks you would expect to get to a product you can then use for analysis. But there is even more features I think are worth highlighting, which are not necessarily new in 8.4, but are sort of new. One of them is temporal algebra. So this is an advanced feature, very unique to GRASS, where you can do expressions, sort of like raster algebra expressions, but these expressions can be applied both to rasters and vectors, and they can also include time, and that's the main innovation here. So this expression here is asking what layers in that data set are their timestamp is lower than the 2005 date. So it will only get the older stuff in the data set, and then it will see which or sum the values in the raster layers in the two data set A and B, but it will automatically match together the rasters with the same timestamp. And it handles all sorts of situations with time where the intervals of the different layers within that data set overlap and not overlap. So it handles all that, figures out what are the things which are actually happening at the same time, and sums these up and leaves the other alone, and that the things which matched are actually your result. So this is a very powerful tool for things like agriculture, but also for analyzing movement of people on a large scale. Another nice tool is RSkyView, which is working sort of like a shaded relief, but it's non-directional. It creates cool visualization, but it also is very advantageous for machine learning and AI in general, because it doesn't have a direction, but it expresses sort of the same thing which shaded relief expresses. So it tells us about a lot about the properties of the surface without being linked to just one direction. And a lot of tools in GRASS are for remote sensing. Here is an example of imagery tool iSuperpixels Slick, which is a segmentation algorithm which is fast, and it's using these superpixels, which are just blobs inside the raster image, which are sort of rectangular. They don't have to be, and they are limited in size, so the segments don't grow indefinitely. They are limited by a specific size, which is what makes the algorithm really fast, but at the same time, it has the same, the resulting image has the same properties as a segmented image, which means it's very easy to classify afterwards. And another strong area of GRASS is hydrology, and there were some latest additions there as well, and there is more actually coming. One of these tools is RAccumulate, which is for fast flow accumulation and watershed computation. And in vector area, GRASS is often used for topological cleaning of vector data, because GRASS is a topological GIS, if you go with that definition, and a lot of the cleaning functionality is present in the vector tool vClean. And here you can see example. This is actually real data. This is not a staged image. This is real data computed in GRASS. So it from sort of a messy data set, it identifies the errors. It can show you what are the errors, and then it fixes the vector. And another strong area of GRASS is environmental modeling. We are using GRASS that way at the Center for Geospatial Analytics, and one of our flagship models is Futures, which is an urban spread model or urban growth model. And this one is very well capturing the way how the landscape will look like with the new growth. So this model is implemented as a set of tools inside GRASS. And all these tools and software, that's like one aspect of the project. But the project is being held together and advanced by a community and a lot of maintenance effort. So let me talk a little bit about that as well. After asking users what they miss and what they would like to see, we realized we need to add an official public project roadmap. This roadmap includes things like currently code quality, community growth documentation, focus on specific way how we are doing software releases, and some advancements in software distribution. There, one big thing which is coming is that we will be creating, or we are creating now and will be releasing a Conda package. So if you are using Conda, Anaconda, it will be much easier to install GRASS and integrate it with other Python tools. It's possible now, but it's more difficult on Windows and Mac. So this will become quite easy now. The roadmap sort of tells everyone what to expect will happen in GRASS. It is also dependent on what people will be actually working on, depending, let's say, on funding or contracts. But it also tells people what is the most welcome contribution to GRASS. So if they are suggesting a change, things on this list will likely be given a priority in a review and integrating into the source code. GRASS is overseen by a project steering committee, which is doing different decisions, including the decision who has access to the source code. We just had an election last October, and we filled roughly half of the positions, or we renew roughly half of the positions every 3 years. So we filled newly 4 positions, and 5 positions are there for another 3 years, and these 4 new people are there for 6 years now. So we have, and the structure of the committee is very simple. There is a chair. Currently it's Veronica Andro, a researcher from Argentina, and everyone else is a member, and there is a treasurer, and that's me. One big thing which happened in GRASS is that we got a grant, and we, in this case, means North Carolina State University, together with Arizona State University, New Mexico State University, and Yale. We got a grant from National Science Foundation after much turmoil of applying for it, to enhance infrastructure of GRASS, revise contributing guidelines, and support community building. It's a grant specifically funding GRASS directly, rather than funding it as part of some other research effort. So as far as we are concerned, that's very, very unique and very nice. The grant doesn't support ongoing maintenance or adding new features, so that's still done in the same way. And this is how it will continue to the future once the grant finishes. And with that, we are now using Open Collective to raise financial support for the project. This primarily goes towards student grants and face-to-face meetings. We would like this to fully fund face-to-face meetings, and on top of that, we would like to eventually raise enough support to finance at least some of the ongoing maintenance. The Open Collective doesn't work for everyone. If that doesn't work for your organization, then let me know. We have now new option, and we can write you an invoice. So that works as well. But official information on that will be coming soon. There is a couple different companies which provide commercial support for GRASS. So if you want like a direct access to someone you want to ask, there are options. These are listed on GRASS website. And there was a lot of things which happened in the project in background as far as maintenance. And one of them is we just launched new tutorials site. Actually, yesterday morning we launched that site. It's grass-tutorials.osgo.org. And this is a one-stop shop for all different GRASS tutorials in the written form, whether it's using Jupyter API or using GRASS from R or using it as a desktop application. The tutorials are here. We are also linking some external tutorials, including tutorials in other languages than English. And we will be adding some tutorials here in other languages as well, specifically Spanish and Portuguese. So this is open to all. So if you would like to contribute your workflow as a tutorial, that's also possible. So that's how we hope to build up the site in general. And we didn't stop there. We also changed the whole GRASS documentation. Generally, the GRASS documentation is highly praised for its content, that it is very detailed. The documentation includes links to the research papers used to implement the specific tools, very important for things like hydrology or solar radiation. But this new documentation brings much better navigation, much better organization, and also much better look. It will also highlight more Python API as opposed to just focusing on the parameters in general and having examples in mostly command line. Another thing is that we launched a new Swag shop. We actually didn't launch it officially yet, so you are sort of the first group which is officially being told about that. We are starting the Swag shop, and it leaked on social media. So the cat is out of the bag, so you can go ahead and try to order things there. One thing which is important is that we are readopting our classic name, GRASS, instead of GRASS GIS, because GRASS does more than just the classic GIS definition. So we are kind of coming back to our classic name. And with that, we are also changing our logo and branding. So this is the new logo. This is already used in the Swag shop, but it's not. This piece is in approval process of the project steering committee. If you are interested in getting more into GRASS, we have mentoring and student grant programs. The mentoring program is when you already know GRASS, but you want to integrate it more into your workflows. The registration for that closes in May, so this is kind of your last chance to do that. The student grants is something we do annually. The call is now open for 2025. So that's specifically for students to contribute to GRASS. So you can consider that or recommend it to people. And one of the things we do is community meetings. The last one was in Prague. We did a lot of work, and remotely you can work on things like working groups, where you can pick your favorite topic and join that working group and work sort of in a smaller group, asynchronously, but more focused. But if you want to do something in person, we have Grass Developer Summit this year in Raleigh, mid-May, and if you really want to become an insider to Grass, you can go ahead and register. But we will also have a user-focused event on Thursday, May 22nd, and we didn't announce that officially yet with registration, but we will do that soon. And with that, thank you for your attention. Questions? We have time for extended questions because this room is free for another 20 or so minutes. So you can ask for something very, it can be a very difficult question too. I can also step down there and be less intimidating. Yes?
I just want to say that Grass can handle very large raster datasets on your laptop. The biggest I've done is 127 billion pixel rasters. Just directly. I don't know. Have you done something bigger?
I'm not sure if I did something bigger on my laptop.
Okay.
But that's a good point. So we did a user survey as part of the grant, talking to 70 plus people for each of them half an hour. I think maybe we talked to both of you, or at least Randy there. And one thing we have found out is that when people use Grass, they often say like, yeah, I don't need to use my institutional HPC computer, supercomputer, or I don't need to migrate to cloud, because with Grass, like my laptop or my workstation just handles all I need, so it's not needed. If they would be using sort of like a Python-only library, like NumPy or something in R, they would have to switch. Let alone some other software packages. But with Grass, it's often just enough to have it on your machine and run it there. Yes?
What American industries are you seeing use Grass? Obviously, we can see some of the things used here. What are you seeing it used?
Engineering, like water engineering. Yeah, so like Grass being integrated into ETL pipelines as tool for either like some basic data wrangling or then really digital elevation models and hydrology.
I use it to generate canopy heights at 20 compression
The Raleigh-based company Natrix is using it for doing their remote sensing part of their workflow. But they have it in cloud with integrated into Airflow. And that's similar how we have seen GRASS being used in some European companies and organizations. Remote sensing and in Airflow workflows. Airflow is like a cloud workflow managing tool. Yes.
Off the top of your head, I don't know if you know, but I was working with Google Earth Engine. Is that observation data set similar, like similar satellites and frequency?
Yeah, so the important piece here is that Google Earth Engine is a platform, specific platform in cloud, which comes with its own data sets. GRASS is just the software, and you supply the data. So migrating from
Observation data set that you were talking about that created?
right. Oh yeah. So that would be importing the data set. So sorry, I was off in there. Yeah. So in that case, you import the data sets, and that would be very similar because the sources Google is using and providing for free on Google Earth Engine. I assume it would be, well, not anymore for free. I'm not sure what's the.
Depends on who you are.
Who you are, yeah, who you are. For researchers, it's still, I think, for free. Yeah. So that will be the same public sources. The EODAC library is pulling. Yeah. Yes.
How does GRASS handle larger data sets more efficiently than some other proprietary software?
Like, how does it handle large data sets? Is that the question? Did I hear correctly? Yeah, so usually very well. As Doug said, it's very often you can, like, if it fits on your like hard drive on your laptop, GRASS can probably handle it. It may, if it is really large and you are doing it on your laptop on like a single core, I am not saying it will be fast, that will take time to compute. But with added parallelization, there are ways to parallelize very easily with GRASS without any scripting. And then with scripting, you can parallelize a lot. And we have, I'm not sure if on the new website we have the tutorial for parallelization specifically, but we do have the tutorial and we will be putting it there. We have some parallelization information inside the GRASS documentation, and some of the tools actually give you information, often in plots, which shows the performance for different size of data set for that specific tool and for different number of cores. So you can sort of, without testing for your specific hardware, you can make a judgment. It may or may not work for your specific case because for big data then it becomes complicated. But you can make a judgment if it is worth it to throw twice as much cores here, or if it is, if you will be able to handle such a large data set. So we try to provide that information because large data sets is what people are using GRASS for. So we are, in the documentation, we are now trying to actually help these users to just like, not to do their own tests every time and every user doing that, but share that information with everyone. Usually also the performance on Linux with anything usually will be better than Windows. So that's why like all the HPC clusters in the top 500 are using Linux, because that's where you get the performance. So Linux laptop will do better than a Windows laptop. Linux workstation will do better than a Windows workstation. So there is that piece. But if you are using cloud, then you will be almost certainly using Linux anyway. So we try to write the documentation independently of the system and write the software the way that you can easily switch in between. So you can like test your workflow on Windows and then switch to some other machine like HPC or cloud and run the same workflow there. There are specific tricks in which GRAS allows. One of them is computational region. I didn't mention it in the talk, which allows you to set your extent and resolution where your data is being computed for rasters. And this will apply to all the computation regardless of the size or resolution of your input data. Meaning that you can have your large input data, but set the computation region just to a small extent and test your workflow, and then you change the computation region to your full extent, and then your workflow should just run the same way. So with these tricks, you are able to do very nice workflows of developing your analysis and then running your analysis in huge extents. Yes.
Do you know what the release schedule for putting Grasp on OSGeo 5 looks like? Do you know if they get the more up-to-date review issues of Grasp, or are they running unstable?
Yeah, so they are using the latest stable release, which is the reasonable choice. So it depends on how the GRAS stable release and the OSGeo Live release align. And if they align the wrong way, then you have a year to wait to include it. And if they align the right way, then you have the latest release there. That's sort of how it works for Linux distributions in general, for better or worse. There are good reasons why it should work this way, but it also sometimes means that you have a outdated software. So for Ubuntu, that's of course not a problem because we have the personal package archive with GRAS, which is called Unstable Ubuntu GIS, Ubuntu GS Unstable, which the IT department doesn't like to see, but it's a technical name for this is the latest stable release for some reason, which dates to some other decision somewhere else. Yes?
Out of curiosity, I don't know if you've tried it, but have you run into any issues with running, you mentioned Linux versus Windows. Have you run into any issues with running it on a full booted PC?
Yeah, no. I think I'm not sure if I did that personally. Yeah, I guess I did that personally, yes. But long time ago, I was using dual boot. I am now using Linux only. I think some other people tried it more recently, but like as far as like dual boot, I don't think there is actually anything which should influence it. So I think that's theoretically that should be safe. If sharing the different directories in between the two operating systems, I'm not sure about that. I know that when I was doing it, I was running into issues, but not specifically with GRAS, because I was just doing everything GRAS on the Linux side of my computer. So that was not an issue.
And have you run GRAS, I guess, on a virtual Windows machine from your Linux PC? Does that make sense?
Right. I didn't do that, but I did run it in a virtual machine in cloud, that works as long as all the permissions align and the installer is able to install with the given permissions on the on that machine. We sometimes in the past we had issues or hiccups along the way, and then we fix it. So now I think we are in a fixed state. Is that? Do you know that? Like permissions, installer permissions on Windows.
I'm not sure.
That means that probably there is no issue, I guess.
You don't need local admin to install it.
Okay, you don't need a local admin to install it. Thank you. Thank you.
Partner will be happy. You don't need to touch the C drive.
Yeah, yeah. Thank you.
Same thing with QGIS. You can run a standalone Windows installer, good.
Yeah, so on Windows you have sort of three ways to install Grass at this point. You install either the standalone Grass from Grass website, or you install Grass with QGIS. There should be an option to have that, or you install it with OSGeo4W. So OSGeo is the open source geospatial foundation for W for Windows. That's OSGeo4W is a sort of a package manager where you can install a lot of different software and you can pick and choose different versions and whatnot. And there is a simple installation, just give me QGIS, give me Grass, so you can do that. Yes.
I just wanted to address that. Installing on Windows, for my IT department, would prefer a standalone installer. Something that they can test and make sure it's deployed. I have run through the same security checks that all your commercial applications run through. And that's what I did at the federal government. My former job is I went through that whole security set of checks for doing QGIS and Grass and other open source programs, the same as the commercial programs. And once you've done that once, you just go back and check whenever there's a major update, like on Grass 3.84, and it's usually just checking the box at that point. But when they're familiar with it, they just say, okay, is there anything different with this binary for the same installer? Not, go ahead. So it's, go to your IT security folks and say, okay, what's the procedure for getting a new program on our system? Let's run this standalone installer that we know where it puts everything, and you can test all the components of it, and then go from there.
Thank you. Thank you, thank you, thank you.
Any issues with Windows 11?
I'm not aware, but issues with Windows in general, yes. There is always some quirks. There is some quirks with how the interfacing with Python and Jupyter works. So I actually have some ideas how to improve the situation. And we are releasing the Conda package, as I mentioned. So this will be yet another way how to install Grass on Windows. And I'm sure it will come with its own issues, but I think that also will be a very good one if Python is your main focus rather than a desktop application. Yes?
I might have missed something earlier. I wasn't here at the beginning of your talk, but kind of building off of what you're saying. Did you say there's going to be an Anaconda package?
Yes. Yeah.
That's great, because I always want to use Grass in Python workflows that I have, but I have such a hard time getting it to work in other Python environments outside of the Grass
Right.
Python. Is there like a way to, if I want to run some LiDAR processes with LES tools and some other processes, if I have like a workflow and I want to be able to call a Grass tool, it has to like stop, my current process, go to Grass, run it there, go back to my other Python environment that has other packages. So will I be able to just install Grass?
Yes. That's the idea, that there will be Grass Conda package, so you do Conda install Grass and you get Grass. So that will be ultimate solution for you, hopefully there. Sorry, when? I hope by the end of this summer. So that's the plan. we do have things which we needed for this are in place. We had to change the build system of Grass completely. We had to change it for other reasons as well, but it was required for Conda, so it was a big undertaking. But we are over the main hurdle which was preventing us from actually working on it. So it's there. So that will be ultimate solution for you and I think for many people, but there is a way how to work with Grass in a different manner, which is more like independent, and that's this. So you could run this as a Python sub-process from your Python workflow, and in this case, it kind of doesn't matter. There might be still some like conflicts of Python and things like that may happen, but this is like the most independent way how to run Grass from a workflow.
Command line interface, sub-process calls.
Yeah.
So, okay, so you can run like RView.
Right. Yeah. So you can exec a whole script. So you can execute Python script. So then you would have still two Python scripts, but one of them would be your native Conda script, and the other would be your native Grass script. So that would be one way how to approach it. And this is what we are using for this interface we are using for HPC a lot. So we can like control Grass from like this way rather than being in Python. So the separation there is nice. So that may be a temporary fix. There might be other ways how to make all Pythons work together, but that is like very convoluted probably. I think this one is more straightforward. The slides have a couple links in them, and the link to slides is at the bottom. So if you're interested, you can grab that. I think that concludes this talk and Q&A. Thanks for staying for this extended session. Thank you.